Hi algebra students, and welcome to Unit 3, which is going to be on functions. At this point we are halfway through all our units. We have 4 units and we just finished 2. So what I've changed about the remaining lessons we're going to see is at the beginning of each lesson we are going to have some review questions just to start helping you review all of this material you've learned and make sure you don't forget it all. So to start, the first review question is, what inequality is graphed below? All right. We learned this in our lesson on compounds inequalities. When I look at it, I notice there are 2 inequalities here. What this graph is saying is that I'm going to use x, but you could choose any variable. But x is a number that is, well, this is all the numbers less than 3. So I would say less than 3. I also want to make sure I'm checking that circle. This is an open circle, which is telling me it's not equal to, it's just less than. So I've got x is a number less than 3, or x is a number greater than 5. Again, that is an open circle. It's not colored in. So because it's an open circle, that lets me know x can't be equal to 5, but it can be greater than 5. So that right there is the first question. The second review question says solve the equation for the variable b, and we have the equation 2ab equals c. Go ahead and try that. All right, for this one here, we've got 2ab. It's all next to each other, which is telling me it's all multiplication. 2ab means 2 times a times b. I'm trying to get b by itself, which means I need to get rid of the 2a. Since it's all multiplication, I could do the opposite, which is division, and come in and divide by 2a. I don't want to divide by b because I don't want the b to cancel. I want to keep b there, and I just want to cancel the 2 and the a. Whatever I do on one side, I've got to do on the other side. So over here, that 2a cancels out, and I'm left with b equals. On the right side, I've got c over 2a, or c divided by 2a. I can't do that division, so I'm just going to keep it as c over 2a. And that would be my final answer. So this was a review question from our lesson on literal equations. Now that we've got some of the, it's black. Now that we've gotten some of those review questions out of the way, we can go ahead and get started on today's lesson. This unit we're about to start is only 2 lessons. It's very short. It's related to what we did in that last unit on linear equations. What we're looking at in this unit is something called a function. So in this introduction lesson, we are going to talk about what functions are and how you identify functions, and then also talk about something called domain and range. We're going to be able to identify domain and range. So to start us off here, I've got the definition of function. We said this lesson is on functions. We need to know what a function is. The math definition of a function is a relation where for each input there is only one output. And oftentimes you see this picture here showing you've got an input, you're doing something to whatever you put in, and then you're left with an output. Before we go back to this math definition, my example I use a lot in this lesson is a soda machine. And you're going to hear me talk about a soda machine a lot, so let me preface that. I use a soda machine as an example of a function because if you think about a soda machine, when you walk up to it, there's a bunch of buttons, right? And when you press that button or your input, there's only one thing that should come out. There should only be one output. So for example, I can press the button for water and I should only have one output. I should only be getting water out. I could push the button for Coke. There should only be one thing coming out. A Coke should be coming out. There might be a lot of different buttons that all say water, but at the end of the day, doesn't matter which one I press, only water should be coming out. If you press the water button and sometimes you get water, sometimes you get Coke, that machine isn't working. It's not functioning. So that's my real world example of a function. Another example you can think of is all of these linear equations we've been doing. Stuff like y equals 2x plus 1. That's an example of a function. Your input is x. And what this is saying is I can put any number here for x, and I should only get one output. I should only get one number for y. So for example, I might put the number 3 here for x. If I do that, 2 times 3 is 6. 6 plus 1 is 7. There's only one number that comes out of it. There's only one answer. It's the number 7, not 7 or 3 or 10. You're not getting a bunch of different options. You're only getting one option or one output. So the reason we talk about functions after these is all of these linear equations we were talking about are also all examples of functions. Now we said in this lesson we're going to talk about like what a function is. Check. The next thing we said we were going to do is identify something called domain and range. Domain and range are the names for the set of all of the inputs, and range is the name of the set of all of the outputs. When you're talking about linear equations, domain is going to be all those x's, range is going to be all those y's. So for my soda machine example, the domain are going to be all of those different buttons on the soda machine, and the range are going to be all the different soda options that can come out of the machine. But we're not going to be talking about soda machines this entire time. When you're talking about algebra, domain is the x's, range is the y's. So using that information, one of the questions you could get is what is the domain and range for, in this example I've got a list of points. I might list them out like this, or we could also see them as a table. Remember we talked about how a table is really just a list of points. In this example though, I've got a list of points written like this. And we want to write the domain and the range. One of the things I want to point out is when you're talking about domain and range, you label the domain as D, and then I've got a colon there. And you use brackets around your domain. So for this first part, the domain, if I wanted to write the domain we just said is the set of all of the x's. So if I'm looking at a list of points, it's going to be all those x coordinates, which are the first number in each of those coordinates. So the domain is all my x's, which is going to be 1, 2, -3, 3, 4, and 5. When you write sets of numbers, traditionally you write them in what we call ascending order. Ascend is just a fancy word for up, going up. So when we say ascending order, we mean start with the smallest number and go up, go bigger. So if I'm looking at this list, when I go to write them all out, I'm going to start with the smallest number, which is always going to be those negatives. Negative is always smaller than the positive. So I've got -3, and then I just keep going up. So the next one would be 1, and then 2, 3, 4, and 5. We can do the same thing for the range. We learned a moment ago that range is just the set of all of your y's or y coordinates. So in this problem, that would be all these second numbers. Those are all our y coordinates. Again, I want to write them in ascending order. So I want to start with the smallest and go big. Here, the smallest is that -7. So I'll start with that. Next would be 0. Next would be 2. Now notice I've got a 2 here and I've got a 2 here. I'm going to talk about that stupid soda machine again. If I was looking at a soda machine and you asked me what was in the soda machine, I'm looking at all the buttons. If there's multiple buttons for water, am I going to tell you there's water and water and water and water? No, not unless I'm trying to be funny. So here, it's the same idea. We're listing all the different possible outcomes. I don't need to tell you that 2 is written twice. I don't need to list it twice. So here, I'm only going to write it once. We don't need to repeat. If it's written more than once in your set, you don't need to repeat that number. So I've got my 2, and then left is 5 and 6. 5 and 6. So that right there would be my range. I said one option, you could see a list of points like this. I could have also put those points in a table, and it would have looked the same. The last option you might see, which students aren't as familiar with, is something that looks like this. Usually in class, I'll have a few students who have told me, I've seen that before, I don't really remember what it is. This right here is what we call a mapping circle. A mapping circle. Mapping circles tell you the same information a table or a list of points is. It's just written in a different way. What this is telling me with these lines, these arrows here, is that there's 3 points. There is a point at 13.5. There's a point at 19.6. And then there's a point at 2.6. So it tells you the same information that a list of points would tell you or that a table would tell you. It just looks a little different. The idea of finding the domain and the range, though, are the same. You don't need to write out the points like I just did. In order to find the domain we said is all the x's. That, for your mapping circle, is going to be that first circle. It's going to be the inputs, which are all of these. Remember how we did it last time. When I write domain, I'm going to label it as D for domain. And then I'm going to use, And then I'm going to use these brackets here. Not parentheses. We use parentheses if you're writing a single point or a coordinate. You use brackets when you're talking about sets of numbers. So I've got a bracket there. And then I'm going to write all my x coordinates in ascending order. So start small, that's my 2, and then go up. So 13, then 19, and close the bracket. So that would be our domain. What about the range? Why don't you try range? Well, our range for this, I'm going to say R for my range, and then bracket 5, comma 6, and then close my bracket. One of the benefits of a mapping circle is we've got 2 points that have 6 as the y coordinate, but I notice I only see it once. So it's already kind of simplifying that list for you. They don't have 6 listed twice. One of the benefits of a mapping circle. These were my examples. I've got 3 for you to try. Yeah. The first one here for this list of points, why don't you tell me the range? What is the range of this list of points? For this next one, this table here, why don't you tell me the domain? What is the domain of this table? And this last one here, tell me what is the domain and the range. What is the domain and range of this mapping circle? All right. Hopefully when you listed that domain, you listed these in ascending order. So you wrote 1, 2, 4, 5, and then the range is nice and easy. It's just -5, only one number. At this point, we've gone over what a function is, and then we've learned how to identify domain and range. The rest of this is going to be on how you identify if something is a function, because not everything is going to be a function. If you want to identify if something is a function, it goes back to that definition of functions. So remember at the beginning of this lesson, we said a function is something where for each input, and remember input you can think of as an x if it's a linear equation. For each input, there is only one output, which remember we said that's going to be your y's. We can use this definition to help us figure out if it's a function or not. So this time we're going to start with these mapping circles. I've got this one right here. The thing we're trying to see is, does each input only have one output? So if I go down my list of inputs, one input, one output, one input, one output, one input, one output, one input, 2 outputs. This part here is no good. Some students get confused by this part here. They see the 2 arrows going here and think that's a problem. That isn't, because this 1 only has 1 output. This 2 only has 1 output. This is the last time I'm going to talk about soda machines, I promise, but I talk about them so much because students find it helpful sometimes. If you're thinking about all of these being like the buttons on the soda machine, this is like 2 buttons giving you the same thing. This is maybe 2 different water buttons, but at the end of the day, it doesn't matter which one you push. They both give you the same thing. They both give you water. The problem is down here. This is like 1 button on the soda machine, sometimes giving you a Coke and sometimes giving you a Sprite. It's 1 button on that soda machine giving you 2 different things. So to answer the question, is this a function? We would say no. We could say not a function. The second part of that question asks you why or why not. I could say it's not a function because, I'm not going to just leave it as a sad face next to the 4. We could say because you get real fancy, use some of that math vocabulary. We could say because the input 4 gives you 2 outputs. Gives you 2 outputs. You could say because there's an x that goes to 2 different y's. You could say because 4 goes to 6 and 4 goes to 8. Any of those would be good, but it's really focusing in on this part right here. That's the part that's the problem. We've got one more. You go ahead and try this one first. What do you think? Is it a function? Yes or no? Well, if I was going through this, again, you're asking yourself, does each input have 1 output? 1 output, 1 output, 1 output, 1 output. Everything's good. So this time we would say, yes, it's a function. For the y, we could say, yes, it's a function because each input only has 1 output. Could write that down, but I just said it. Something along those lines would be a good reason. So these are all the mapping circles. I like to start with these because I think it's the easiest ones to see with the arrows. I really want to focus in on here what it would look like if it was written as a list of points or in a table. This right here would look like 4, 6, and 4, 8. So if I gave you points, or if this was in like a table, an XY table, the problem is when you've got that same X coordinate going to 2 different Y coordinates. Something like this would be a problem if it was written as a list of points or in a table, which is what we're doing next. So I've got 2 last examples. One's a table, one's a list of points. What do we think about this table here? Is this a function? Why or why not? Well, here, I notice I've got the same X coordinate going to 2 different Y coordinates. Sometimes students have to change this back to a mapping circle to help them visualize it. This is saying there's 4 going to 3 and the input 4 going to 5. That is no good. So your answer for this should have been no, it is not a function because one input, the input 4, goes to 2 outputs. Goes to 3 and to 5. It's like the soda machine button giving you 2 different things. There's one last one, this one here. What do you think? Is it a function? Yes or no? Why or why not? Well, this one here, sometimes students get hung up on the fact that that y of 10 repeats. Remember, we're checking to see if the input or your x coordinate has a different output each time. I noticed that all of my x coordinates are different. That means each one's only going to 1 output. That 0 is going to 1, the -1 is going to -2, the 9 is going to 10, and the 4 is going to 10. But each of those inputs only goes to 1 output. So this one right here would be a function because each input only goes to 1 output. it is time for you to try some of these. So I'm going to erase all of this. Same question. Is this a function? Yes or no? Why or why not? Is this one a function? Yes or no? Why or why not? You should have said for this one, no, because that input 0 goes to 2 outputs. This one is all good. What about the last two? For this one here, is this a function? Why or why not? Is this a function? Why or why not? This one here is all good to go. Each of those inputs only goes to 1 output. This one right here, though, is no good because that input, -5, goes to 2 outputs. The last part of this is looking at graphs. But before we move on to graphs, I want to use our answer for this one to see what it would look like with a graph. So, looking at that last table there, remember we said this one, all I've done is move it up here. We said this one here is not a function. And our reason for it not being a function specifically is because of these 2 points here. Those 2 points are the reason it's not a function, because that one input goes to 2 outputs. Well, what would that look like on a graph? If I were to graph all of these points, -3, -5, -3 would be starting on our x-axis at -5 and then going down 3. So that's 1, 2, 3. That's right here. The 1, -2 is going to 1 on our x-axis and then down -2. That would be right here. Then we've got 0, 1. That's 0 on our x-axis and then going up to 1. And then this last one here, -5, 4 is going over to -5 and then going up 4. 1, 2, 3, 4. And to kind of point out here, we just said one last time, the reason this is not a function is because of right there, which would be these 2 points here. Do you notice anything about those 2 points on the graph? Well, in our table, remember they have the same x-coordinate. So on our graph, what it means when they have the same x-coordinate is notice those 2 points are on the same vertical line here. They're on top of each other. They're on top of each other because they both have -5 as that x-coordinate. They just have different y-coordinates, which means they're at different heights. Now, this is a graph of something that's not a function. Because all I did was I took these points and graphed them down here. I'm going to change this table a little bit. So before we said it wasn't a function because that -5, those 2 lines with -5 had the same input and different outputs. But over here I changed it to a +5. If I change it to a +5, is it a function now? Well, yeah, sure. All of our inputs are different. They're all going to 1 output. So this right here would be a function. What would happen to the graph? Well, these first 3 points would be in the same spot as I graphed them over here, right? Those didn't change at all. So it would be -5, -3. It would be 1, -2, 0, 1. The difference is this last point now is at +5, 4. So over 5, up 4. So that last point would now be here. And this right here would be a graph of a function. I do all this to kind of help lead us into this last part. This last part is going to be looking at graphs and deciding if they're a function or not. Well, what did we notice over here about these 2 points? We noticed when it was not a function, that meant on the graph there is 2 points on top of each other. There were 2 points on that vertical line right there at -5. But when it is a function, because none of those x-coordinates are the same, there are no points on top of each other. Nothing is on that same line there. That's going to lead us very nicely into this last part. If you are given a graph like these, so a graph with points or a graph of a line, you are looking to see just like this one here, if there are points on top of each other, if there are points on that same vertical line. If you are given a graph, we use something called the vertical line test. What the vertical line test tells you is if you can draw a vertical line that only passes through one point on the graph. If every vertical line you draw only passes through the line once or only passes through one point, that means it's a function. The opposite is also true. If you can draw a vertical line that passes through more than one point, it means it's not a function. So for example, that last one we had points, I'm going to use a line this time. If I can draw a line like this, this looks a lot like those linear equation lines you were graphing. You can draw a line where every single vertical line I draw through it, here and here and here, that every single time it only passes through one point, that means it's a function. If you have a graph, let's do something like this, where you are able to draw a vertical line through more than one point. So notice here, I can draw a vertical line and it's passing through more than one point. If you can draw a vertical line that passes through more than one point, it means it's not a function. So notice we're looking at whatever that graphed line is and seeing, can you draw a vertical line through it that passes through only one point or passes through more than one point. So to give us some actual examples here, I've got these 6 questions here. I'm going to start down here with the circle, I think. I'm going to jump around a little bit. Looking at this circle, I want to ask myself, can I draw a vertical line that passes through more than once? If I can't, it means it is a function. But if I can find a vertical line that passes through more than one time, it means it's not a function. So for this circle, I'm going to look at it. I'm going to focus in just on the circle. Ignore those x and y axis. Can you draw a line through that circle that passes through the circle more than once? Yeah. If I draw a vertical line right here, it crosses through more than one time. If I draw a vertical line over here, that's more than one time. I've got vertical lines passing through more than one time, so my answer would be this is not a function. No, not a function. What about this one right here? What do you think? Can we draw vertical lines that pass through more than one point? Remember, I'm focusing just on this diagonal line. Don't worry about the x and the y axis. Let's draw some vertical lines. Here, well, here it's only passing through that red graphed line once. What about down here? Only passing through that red graphed line once. Here, only passing through it once. Every single line I draw is only passing through that line one time. If it only passes through it one time, that means, yes, it is a function. Let's try a couple other ones. What about this v? Function, yes or no? Well, this right here, if you focus on that v, I can only draw lines that pass through it one time. So that would mean it's a function. What about this backwards c? Yes or no? That one would not be a function because we've got a vertical line that passes through more than once. What about down here, this horizontal line? If you focus on that horizontal line, it's only crossing through one time. Don't get confused with that x-axis. We're only focusing on that graphed line. It only passes through one time, so that would be a function. And then this last one, this mixture of points. Well, if I draw vertical lines through every single point, it helps me see that none of those points are on top of each other. Each vertical line only passes through it once, so that would be a function. The last thing I've got for you today is your own set of examples. I'm gonna erase all of this. Okay. Go ahead, just try these first two. Are these two functions, not a function? mixture. All right, this one is a function, this one is not. I know it's not because I can draw a vertical line that passes through it more than once. What about those last two? All right, this first one is a function, the second one is not because there are places where I can draw a vertical line through more than one point, so that would mean it's no good. Thank you so much for watching this video on functions. Remember, I said this unit is only 2 lessons, so we're starting the unit today, and then we'll end it tomorrow. So I will see you back tomorrow to talk more about functions. Bye.